Today we will look at the sine and cosine ratios. They are functions. In other words, they require an angle to be used. Just like we would ask for the tangent of a 20 degrees, we can also ask for the sine or the cosine of 20 degrees. And our calculators, again, will have these things memorized for us. But we have to know the ratio so we can apply that to solving triangles. So let's go ahead and look at these two functions. The sine ratio here. Sine is opposite over hypotenuse is the thing you want to remember. The ratio of the opposite side and the hypotenuse of an acute angle. So again, we have to reference an angle. So it's not enough to say sine. You have to say sine of what angle in the triangle you're talking about, and then write the relationship, or the ratio rather, relative to that. So, for example, if I want to do the sine of A here, angle A is up here, and now we want the ratio of opposite to the angle. So opposite is still the same thing it's always been, opposite it, relative to A, over the hypotenuse. Well, the hypotenuse doesn't depend on the angle. It is always the same thing. So for sine A, we'd say side CB over hypotenuse AB. And then when we do sine of B, we'd have to look at angle B, but now the opposite side is AC. So the opposite would be AC, but our hypotenuse would still be AB. It did not change. Okay, some other things about sine. The abbreviation is, it looks like sin, but we pronounce it sine. It is opposite over hypotenuse. Now, we had a little phrase for tangent. We said TOA, opposite over adjacent. For sine, it's opposite over hypotenuse, so it's so. So and TOA. And then let's cosine function. Cosine function, we use the adjacent angle, which we have not used yet. So cosine is adjacent over hypotenuse, just another ratio. So we have three different ratios, and they have three distinct names. If I want the cosine of A, I have to use its adjacent side, which is AC, over the hypotenuse, but again, the hypotenuse is always that longest side. So AB, and then when I do angle B and I want his cosine, the adjacent side is BC, and again over the hypotenuse, but the hypotenuse does not change. So AB again. So cosine is abbreviated cos, C-O-S. It is adjacent over hypotenuse, so that's the ca. So we have this little phrase here. So ka toa. SOHCAHTOA is the phrase that many students memorize to remember their ratios. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Let's go ahead and apply these things. We are going to find the, I hope you guys can see all this. We're going to find the sine and cosine ratio of each acute angle, so let's start with angle Z. And since we're doing both, we'll do cosine Z and we'll do sine Z at the same time. For cosine Z, this is ca, so it's adjacent over hypotenuse, and your hypotenuse again is the longest side, the side across from the right angle. So adjacent over hypotenuse, 15 over 25, we can reduce that to 3/5. Sine of Z, we want opposite, this is so over hypotenuse, so 20 over 25. And we'll reduce them by 5 4/5. Now let's do angle X, cosine of X, and the cosine, there we go, and the sine of X. Let's erase our marks, leave the hypotenuse there. Okay, cosine, so ka, adjacent, which is 20 over hypotenuse, 25. Divide by 5. Sine of x is opposite, so got to opposite over hypotenuse, so 15 over 25. Divide by 5. And we get 3/5. It's interesting, something we should know here, z and x, they are complements of each other. In other words, they add up to 90 degrees. And the cosine of z is 3/5, and the sine of z, or sine of x, but x is the complement of z, is also 3/5. Just a fact we'll use later on. Let's do another one of these. Right, awesome. How about right? And get rid of that and that, put an E on the end. Right, the sine and cosine ratio. Let's do sine of, let's see, C and cosine of C. And then we'll do the sine of A and the cosine of A. Starting with sine of C opposite over hypotenuse. So 36 over 45. Cosine of C is adjacent over hypotenuse. I'm going to write them all down and simplify at the end. Sine of A opposite over hypotenuse. And cosine A adjacent over hypotenuse. And then we just simplify each of these fractions. Divisible by 9. Divisible by 9. Divisible by 9. 9. Yeah, there we go. 3/5. And divisible by 9. 4/5. And we're done. This example is the same thing, except it says round it to the nearest tenth, so you're going to need to get your calculator out for this. So sine of A, cosine of A, sine of B, and cosine of B. So it's just important to remember that what the ratios are. So sine is opposite over hypotenuse, cosine ca adjacent over hypotenuse. So when you go sine A, just go opposite over the hypotenuse. Hypotenuse, remember, always across from the right angle. So you know that's going to be the denominator for both of these right away. For cosine of A, though, here's my angle A. I've got to use the adjacent side, so that's 36. Sine B opposite, so not B, those should be C's. There we go. Sine C opposite over hypotenuse. Cosine C adjacent, 27 over 45. Divisible by 9. Divisible by 9. By 9. And by 9. Let's get decimals for these. So this one's 0.6. This would be a 0.8. 8 and a 0.6. Same deal. Sine A opposite over hypotenuse. And then cosine A has to be 48 over the hypotenuse. Sine of C in this case, opposite is 48 over hypotenuse, and cosine adjacent, which is 14 over hypotenuse. Because we have to go to the decimals here, I do want to write it as simplified fractions. Everybody's divisible by what? 2, 7, 25th. Everybody's divisible by 2 again, I think is all 24, 25th, 4, 25th, divisible by 2, 7, 25th. Then as decimals, says to the nearest tenth, well, this would be 28 hundredths, so to the nearest tenth, 0.3. This would be 90.96. So if we rounded this to the nearest tenth, it would be 1.0. 48 again would be 1.0. And 7/25, we just did that one. That's going to be about 0.3 to the nearest tenth on all of those. Our calculators can do these things as well. I don't have my calculator pulled up, but I will here shortly. You aren't going to be able to see this, unfortunately. But I'm making sure my calculator is in degrees. I'm just typing in the 20 and hitting the cosine. And it gives me 0.94. And cosine of, why do I have cosine of 20 there? Again, it should not be cosine of 20. We should be doing the sine of 20. Don't need any of that business as well. But again, we just pull out our calculator and we find the sine of 20. And sine of 20 comes out to be 0.34. Okay, so just use your calculator. These are just more practice problems. Try them on your calculators. I will give you the answers to these, though, so you can test them as well. 35 sine 35 is 0.57 to how many? 4 decimal places, they say. So let's make sure we do it like we're asked to. 5736. 45 cosine is equal to 0.7071. The sine of 100, I get 0.9848. And then lastly, the cosine of 5, I get 0.9962. Okay, so just straightforward calculator problems. And that leads you to your homework. And that's it.